keeping track of climate change with swarms of collaborating mini-satellites, scanning the universe for life on exoplanets and providing secure, high-bandwidth communications for all. These are some examples of what we work on at the Department of Space Engineering. Let's meet some of their people and have a look at their labs.
Welcome to the clean room. This is the cradle of our spacecraft. With equipment in here, such as a vacuum oven, Helmholtz cage used for testing attitude control systems of nanosatellites, we build and test our own spacecraft. We can even monitor our satellite because we have our own ground station. Here you can see Delphi PQ flying over. It's one of our labs in space, and it's the smallest of all. It's only 5 by 5 by 17 centimeters. These tiny satellites are designed to work as worms.
None of this work could be done without excellent space instrumentation. Professor Jerome Luick heads the Space Instrumentation Lab, where we study how light interacts with matter and develops tools for things like Earth observation and satellite communications. This optical table, for example, is equipped with interferometers to measure the chemical composition of the atmosphere, such as traces of greenhouse gases. At the Satellite Communication and Orbital Mechanics Lab, we test space tools. Let's go up and check it out. Rudolf, can you tell us why we're on the roof?
Yeah, we're here on this lab with this fantastic view. Here we have access to the sky. We want to pursue optical communication with satellites and also track their movement. The Advanced Weather Station is there to link the weather conditions to the quality of communication and tracking. We have radio frequency antennas to track the radio frequency signal from the satellites to do Doppler tracking, and a camera that tracks meteorites. So what we want to do is improve optical communications to improve their speed, but also safety for better internet and worldwide internet.
Collisions with space debris may disrupt these communications. Here in the GNC Robotics Lab, we're testing a controlled fly-around of a malfunctioning satellite to inspect debris damage. But that's just one of the many things we're working on. Our robotic systems also advance key space technologies, like satellite docking and formation flying, essential for future space missions. A lot of our work focuses on space applications, but that's not all we do. We also deepen our understanding of our solar system. Stephanie, can you tell us what you do here?
Yeah, here I am in the Delft Planetary labs, and in these labs we're recreating environments that are typical of our solar system bodies. And in this room, we are looking at icy moons orbiting around Jupiter and Saturn. We are recreating geysers. These geysers, they form from the subsurface ocean, escaping through cracks in the icy crust that give some jets at very high velocity. We're also looking at the effect of radiation on icy surfaces with another type of experiment. What we want to do here is to look at how to develop new type of instruments, how to understand better our solar system, how it formed, how it evolves, and also look for life in our solar system and maybe on these icy moons.
That's fascinating, Stephanie. Did you know we can also learn a lot just by studying our own planet? Sebastian, how does that work?
Hello, I am Sebastian de Vet and I'm a planetary scientist. And using equipment like, for example, this drone, we can study Mars. Well, actually with a little detour, because this one isn't flying on Mars, but here on Earth. And we can use these drones to map places on Earth that resemble the surface of the red planet. And by doing so, we can actually study landforms like rootless cones that we find in Iceland to better understand the ones that we find on Mars itself. And hopefully in this way, we can actually learn something new about the evolution of the planet Mars.
I'm sure of it, Sebastian. Thanks for visiting the Space Engineering Labs with me. Want to explore some more? Join me on the other lab tours. See you there.